Welcome back. I'm Harry Powell, Head of Industry Solutions at Tigergraph. And this is the fourth part of our series of talks about machine learning and graphs, networks, connected data. And last time, we talked about graph neural networks. This time, we're going to talk about some intuition on why graphs are so powerful. So, graph neural networks, being used by, some of the top performers in the world in terms of machine learning to build their machine learning models. I gave you some prediction about how I think they are going to be the tool over the next few years in businesses, and they're already being used. But I wanted you to not just get excited about the opportunity, understand a little bit about why they were so powerful. So this talk, perhaps a bit shorter than some of the others, I want to give you a bit of intuition. Also like you to recommend you to kind of find out in depth, right, technically why they work, right? But this isn't going to be a technical talk so much, but more of a kind of imagine why they're so good kind of talk. So I hope that'll give you some intuition and that'll be useful. Okay. So why is there a picture of a rib cage up there? Okay. So you got to think about the job of a neural network, of a deep neural network, one with a number of layers, right? What is its job? What is it trying to do, right? It's really trying to do two things at once. And I'm going to argue that by using the graph, you kind of you simplify one of those things down so it can focus all of its effort onto doing the second, right? That's one reason, right? It simplifies the machine learning process. So what do I mean by that? Well, and why is there a skeleton there, right? Okay. So when think about the neural network as a bunch of layers fully connected, right? All those connections, right? Effectively, the neural network's doing two things. It's learning the structure of the network, running the structure of the deep neural network, right? It's trying to work out which links are important. In other words, which nodes in that network are affecting the other ones, right? And then it's got a prediction task. How do I predict the output, right, in a way that is useful to whoever's built this model, right? It's two things: learn the structure, learn learn the prediction task, right? And that's why I put the skeleton up, right? You got to learn. It's kind of like, how do I produce the skeleton, right, that I hang, and then how do I kind of put the body on top of that, right, in some sense, right? And the skeleton is the structure here, right? Graph neural networks uses your expert knowledge, or your business's expert knowledge, of the way the world fits together to preset that structure, right? Because it knows, your business knows, your data shows that only certain people can be connected together, right? Only certain people can influence each other. So the deep neural network, which has everything fully connected and has to learn through the data who is connected to another, it's doing an enormous amount of work to work out what those connections are. You can kind of you can front run that. You can get around that by saying, no, I know who's connected to one another, right? I don't need to look at, what transactions have happened and all sorts of features and run it through the model a gazillion times and do all this kind of particular loads of propagation and stuff in neural networks, right? I know who can be connected together. I know that maybe on a car, I keep talking about cars, okay, on a car, there's the wheel is connected to the axle, right? That the engine is connected to the fuel tank, right? I don't need the graph neural network to work that out. I know that already. By putting that structure into your graph, into your neural network, the neural network is kind of, its task is much simpler, right? It's like, okay, how do I focus on the prediction task? Given what I've been told about the way things connect together, how do I then predict what the right level of inventory should be, or what recommendation I should make, or what the level of demand for a certain part or product will be? I can do that without thinking too much about the structure. Okay, and so still have to learn the weights on the connections you have allowed, right? So it's still got that kind of thing to do, but it's not learning the overall structure. It's much, much simpler. That super boosts the power of what you're trying to do here. So that's number one. That's the number one reason why graph neural networks are good, right? I'm going to give you a couple more. So the big step forward in deep neural networks, I don't know, whatever it was, 10 years ago, perhaps a bit more, was the use of convolutions in things like image recognition, right? This is the idea that you don't need to recognize a face all in one go. You can learn to recognize the nose, the mouth, the eyes, right? Different kinds of eyes, different kinds of noses. And if you're trying to recognize the face, you effectively create these things called convolutions, which are local pooling of information, right? Local pooling of information, not for the whole picture at once with all the, thousands of pixels available, but say, just in this area, let's see if we can detect a nose or an ear or whatever it is, right? That's what this picture is on the left. It's kind of the beginnings of convolutions. It effectively, again, simplifies the learning task. It says, don't try and learn everything at once. Just start locally and then grow from there, right? Graph neural networks localize things, right? Because they start by saying, these people are connected, right, together directly with a first degree connection. Let's learn a little bit about those. And then in the next layer, let's learn about the second degree connections, the people who are connected to those people, right? And the third layer a bit further afield. It allows you to be local, right, in the way that convolutions are. Right. In fact, that's exactly what convolutions do. They've done exactly the same as neural networks, but in a much more kind of rectilinear sense. Right. They've said, what are the allowable connections? Initially, the allowable connections are all the pixels that surround one another, right, in image recognition. Right. And then you can go, OK, so what pixels surround them, or what once I've created these little convolutions, how do they fit together, right? That's exactly what a graph neural network does. You can think of it as a kind of an arbitrary, a convolution of an arbitrary shape, right? That localization makes life much, much simpler, again, for the graph. The graph can concentrate on, the neural network can concentrate on doing a simpler task and then building those tasks up together to think about prediction. So that's another reason why graph neural networks are really cool. And then finally, graphs allow neural information to diffuse across the network. In some sense, all these three things I've told you are the same thing, but they're just different ways of looking at it. This is a picture of a crowd, and I want you to think about how perhaps each person in the crowd can talk to one person next to them, right? So one person in the crowd can say, I don't know, let's take a personalization thing. I like strawberries, right? Maybe you can buy strawberries on the internet. I don't know, right? And then the people around, each person around them can say, well, they can transmit that information on and go to their neighbor. Well, this guy likes strawberries, but I like raspberries. Okay, and the person beyond there goes, well, I like raspberries too, and I'm kind of keen on strawberries. And gradually information percolates out. So you can start learning what other people learn, not through direct connections, but through some kind of information diffusion process, right? And again, that makes this kind of incredibly powerful, because you can effectively filter out what matters and what doesn't matter through this kind of passing of messages one to another. In fact, we call this a message passing paradigm, and that's exactly what it's doing. And it allows different parts of the neural network to focus on what matters around them. So perhaps this is another example of localization. Okay. So what I'm trying to get across here is that I'll go back. There's reasons why putting a graph in the way that it does works in the way that it does, right? It localizes like a convolution. It allows information to flow between nodes, and it simplifies the learning task. It stops the graph having to learn about the structure as well as the output at the same time. Well, we mentioned this before, tyGraph Machine Learning Workbench. If you're not bored of me talking about it by now, I think it's really cool. tyGraph is a great graph database, and we talked about that, I think, in talk 1. Machine Learning Workbench I've talked about throughout, and it's a way of connecting the graph together with whatever your favorite machine learning platform is. Whatever you're doing right now, you can do that, and you can build graph neural networks as if they were native, right? So make sure you have a look at that. And summary of where we've got to, right? There are good reasons why graph neural networks perform so well. This isn't magic, right? This is taking the state of the art in machine learning, right? In deep neural networks with the sort of structures of convolutions and stuff that are used throughout there, and effectively shaping them with the way we know the world works through the graphs that we've got, right? That's what we're doing here. And so it's not a fad, right? This is a real thing, right? There's a reason why they work the way they work. It's not magic. And I strongly recommend you look more deeply into it. Strongly recommend that you look into Machine Learning Workbench as a way of doing this. It's not the only way of doing it, but I think you'll find it's probably the easiest and quickest way to do it at scale with tidegraph in the background. Next time, we're going to talk about how to implement graph neural networks practically in production using tidegraph and tidegraph Machine Learning Workbench. Hope you'll be able to join me in that. And just in the meantime, if you want to get playing with or using tidegraph for free, 50 gigabytes for free, you can get that in the cloud, tidegraph.com/cloud. And if you'd like to talk to me, if you could put up with me any longer, right? If you're prepared to talk to me anymore, want to know any more about this, I would love to talk to you about it. I'm passionate about this thing. I think it's the next big thing. It's not even next, it's happening now. You need to be in on it. Please get in touch through sales@tidegraph.com and I'm Harry Powell, and ask speak to me. I hope you will join me for the final part where we talk about practical implementation. Have a great day, and thanks for your time.